Welcome to another edition of the Heavy Duty Parts Report. I'm your host, Jamie Irvin, and today we are live. With all of our live broadcasts, we want you to be part of the conversation. So please, if you would like to comment today or ask a question, we'll do our best to incorporate you into today's broadcast. Also, I wanted to just remind everyone that our podcast, which is a pre-recorded edited conversation with heavy duty parts specialists as well as industry experts. It's part of our main weekly broadcast that we do. We air it on Mondays. So if you're watching this on social right now live and you'd like to check out our podcast and be able to listen on the podcast player of your choice, you can watch the video version on YouTube, or you can actually watch or listen directly on heavydutypartsreport.com. Head over there today and make sure that you sign up so that you don't miss out on any of our new content, which comes out every single Monday. Now, today, what are we going to talk about today? Well, if you're operating a fleet of commercial trucks, your largest costs are the drivers, the fuel consumption, and the insurance. And if there's any way that we can lower the total cost of operation for fleets, then I think we're doing our job and in supporting the trucking industry, which of course, as many of you know, I feel very strongly that the trucking industry is the backbone of society, and we need to do everything we can to make them more successful, because if the trucking industry is successful, society at large is more successful. So this is an important subject, and today we're going to introduce you to a technology that really has the ability to lower costs on all three of those fronts that we were talking about. So driver, fuel, and insurance. We're going to focus pretty heavily on the fuel side of the conversation, but there is these other benefits that we're going to learn about as well. Ali Maleki is the CEO at Traxen. This is a Michigan-based technology company which is offering an AI-based intelligent cruise control system. This is high tech for the trucking industry, and I'm very excited to learn more about it. Ali, welcome to the Heavy Duty Parts Report. So glad to have you here.
Hi, Jamie. I'm glad to be here. I appreciate the opportunity to speak to you about how we are contributing to reducing trucking technology's pains and improving efficiency.
Well, just before we got on the live broadcast, we were talking about some of our background, and I know that you're a serial entrepreneur. You're a man who's always looking to try to solve problems. So I'm excited about learning what this latest company that you're involved in is doing. So let's get into it. Right off the bat, how much fuel can be saved per year with the IQ cruise control technology that you're developing? I want people to understand what's at stake here.
Sure. So, Jamie, let me give you a bit of a background as to how much opportunity there is in terms of driving style. Today, trucks have aerodynamic drag reduction components, low resistance tires, very high efficiency powertrains. Engineers have put in a lot of effort into making components a lot more fuel efficient. The final frontier is how you drive that vehicle. Can you drive that vehicle more fuel efficiently? I'm sure you're familiar with the concept of these hypermilers, the folks that are driving vehicles and they are in competition with each other to beat each other's MPGs. So the hypermiling record for Toyota Prius is, to my recollection, is 140 MPGs. Wow. Meaning that is the opportunity that you can get to that. Driving style really has a huge impact. And if you talk to fleets, and from a lot of the research that American Transportation Research Institute has published, drivers have up to 35% impact on fuel efficiency. So
let me just Ali. So what you're saying is that same truck, same route, there is the possibility of a swing of 35% on fuel consumption depending on driver habits.
Exactly. So that is the bell curve within the fleets when they plot their best and worst drivers. There's a 35% spread. So our system is engaged. We engage it currently on freeways only. It's similar to an adaptive cruise control solution. We call it IQ Cruise. We will talk about how much more than adaptive cruise control our system is. So we are reducing the fuel consumption repeatedly on average at 10% rate. So 10%.
So that's 10% across all drivers in a fleet. So let's say we have like 100 drivers, and some of them that we've already got this range based on driving habits, and your system comes in and on average just slashes fuel price consumption by 10% overall.
Yes. So obviously, the system improves the worst drivers far more, and it improves the best drivers less. But on average across the fleet, right now our record is 10%, which
That's
translates to, with the current fuel prices today at about $3 a gallon, with the average MPGs and with the number of miles that the trucks are putting on vehicles, it translates to around $5,000 a year per truck.
per
And
truck.
we provide a less than 1 year payback, which is very significant.
Right, that return on investment is so important. It's one thing if, we get this technology and we install it in our trucks and, it takes 5 years to recoup our investment, then you've made a lot of money, but the trucking industry is thinking, well, I don't know how much that's helping me. But that quick turnaround on ROI is significant because it pays for itself in the first year, and then every year after that, that money is just going straight to the bottom line. And when you start to do the math, $5,000 per truck, 100 trucks, 500 trucks, 2,500 trucks. This is significant.
It is. It is. If you look at the average margins that trucking fleets have, is right now it's at about 4%. Fuel cost is on average, is a quarter of their total cost. Is 25%. If you take 10% out of that cost, 2.5% goes to the bottom line. So an average margin of 4% becomes 6.5%. That is a 50% improvement in margin for a fleet. That is transformational for a fleet's stock price and valuation and operations, where fleets are trying to, today, fleets are trying to a lot of them keep their heads above water. But if you improve their margins by 50%, that is transformational.
Every company has an ideal customer. What is the ideal truck that can be retrofitted with your technology? I'm sure that there's outliers on either end of the spectrum, but give us an idea of who what vehicle owner are we looking to attract with this technology?
Right. So there is a drive cycle dependence and there's a vehicle type dependence. Drive cycle is, we like to have the vehicles to have as many miles as possible. The more miles, the more fuel, the better the ROI is. And today our system works at speeds of above 20 miles an hour, 22 miles an hour, in fact. So it's more suited for freeways. So the more freeway miles, the more suitable that customer is. And then the second, the technology dependence is, today we support AMTs or automatic transmissions. The system works with those. We are working on supporting the manuals as well. Our next software release will support manuals, and our next software release is scheduled for first quarter of 2022.
Okay, so like if you're driving like a Volvo with an I-shift and you are doing a lot of highway miles, maybe you're doing a regional route or a national route, that sounds to me like a perfect customer for you.
Absolutely. Yes.
That makes sense. That makes sense. The manual, that's going to be a big update for you because that's going to open up a whole other group of customers.
Exactly. So what we're doing with IQ Cruise, because we're offering it in the aftermarket, we're providing a major boost, a shot in the arm, if you will, during these COVID days, to the legacy vehicles that are on the roads. There's a lot of investments made in those vehicles, and there's no sense. My whole motivation has been to help reduce carbon, and as in a holistic way. If we want to throw away all of these legacy vehicles, even if they're less fuel efficient, the amount of energy that has gone into their production, and then the amount of energy that it would take to recycle them, that far outweighs, walking away from the investment. So we are providing a shot in the arm for all of these older vehicles that can get ADAS content, that can get their fuel efficiency improved and become similar to a modern vehicle, as well as modern vehicles will benefit from our technology, because now we have a significant amount of improvement on hybrid electric and all electric vehicles as well. And we extend the range for CNG vehicles. The charging stations become more accessible, so that range extension applies across the new and old trucks.
Okay, we got to unpack what you just said because there is a lot there. So let me make sure I understand correctly. So what you're saying is that we've already created the carbon emissions when we manufactured the truck the first time.
Yes.
So let's say we manufactured it back in 2014. It's been on the road for a few years now. We've already that carbon's already been emitted. And
Yeah.
so if we just take that truck and scrap it and go build an electric truck to replace it, we're actually being inefficient. And we're actually, because there's still a lot of energy that is required to build that new truck. So what you're saying is, let's reduce the impact of the final few years of that truck we built in 2013 or 2014, and let's reduce the amount of carbon emission for the second half of that truck's life. So that's one way that your technology is actually helping with a carbon reduction. Do I have that right?
Absolutely. It's looking at it from the big picture point of view.
That makes sense. That makes
In
sense.
not to
And I wasn't
manufacture a complete new truck and have an inefficient truck be less inefficient.
right.
Make it be more efficient and keep its life cycle slightly longer, or maybe a lot longer. That is a whole lot better for the environment and carbon reduction than it is to throw that away or recycle it. Exactly as you stated it. A lot more, succinctly than I had.
I something comes to mind too. Not that long ago, CARB, the Air and Resource Board for California, they released this 10-year study on the impact of biodiesel versus fully electric. And what they were saying basically was, when we look at our standard diesel trucks, they're measuring from the well to the wheel of that diesel truck. And when we look at electric, we have to do from the power plant to the wheel, not just from the moment the truck rolls off the assembly line and starts being in operation. And
Yes.
when you adjust for those numbers, there's actually good reason to say, look, there's some great applications for electric, but there's also an opportunity to do biodiesel, and your technology could actually bridge the gap for these traditional diesel trucks, because converting them to biodiesel is actually not that big of a deal. So if your technology lowers emissions in that window of time between where we are and where we could be with advancement in biodiesel technology, this is where we attack the problem from all fronts. This is the only way I see us solving these big issues.
Exactly. It's an evolutionary and incremental way of attacking the problem. And in fact, we are attacking the carbon emissions reduction and energy efficiency reduction in the same way as we're attacking autonomy and self-driving. Our solution is a semi-autonomous driving solution. We are solving the simpler dimension of the problem, which is the longitudinal speed control of the vehicle. There's no regulatory barriers to that. The technology readiness is there. We can leverage all of the full self-driving AI tech that has evolved over the last 10 years, apply it to a single dimension of the problem, and provide the self-driving and work towards that fully automated solution in a TBD, maybe 8 to 10 years, when we can deploy those, and then solve the lateral control problems. And now we have a higher level of logistics and drivability on all roads. So right. It is our strategy, incremental, step by step, understanding the market, understanding the customers, and what can we do now, and not plan for an indefinite future. By then, the technology will be completely different. There will be lots of new technologies that we can deploy. But let's solve for what we see today and 2 to 3 years in the future.
Right. So the IQ technology, IQ Cruise, explain to us what the difference is between traditional cruise control, adaptive cruise control, and what your technology really is.
Great question. So I'll answer it while I contrast IQ Cruise against those. So traditional cruise control or adaptive cruise control systems, they work in either speed control mode or in following distance control mode, keeping you at a set speed that you press the speed at, or they keep you at a set distance behind a lead vehicle. And then there's predictive cruise control systems that take a slight amount of road grade into account. Our solution is an artificial intelligence-based driving system that takes a more holistic approach to the whole thing. So IQ Cruise works by using radars, onboard high-definition maps, wireless connectivity, and AI to first keep you at a safe distance from all the vehicles around you. We understand the driving scenario. We synthesize the entire scenario, whether you are in a passing mode, whether somebody's cutting in, whether you're approaching an exit, whether there's a merge line coming to your lane. And we modified the driving behavior based on those situational awareness conditions, as well as fuel efficient driving response to every one of those conditions. Second, IQ Cruise knows your route. You have entered your route into our maps, or we're predicting your route as we're going. So we keep an eye on a medium-term horizon of up to 3 miles. And we know the upcoming curves, grades, speed limits. We're also getting over-the-air traffic backup information and weather telematic information. And we're planning accelerations and speed through that entire horizon with an optimization of fuel efficiency. It's basically hypermiling in software. And finally, we are connected with the vehicle's ELD and fleet telematics, and we know the driver's hours of service. We keep into account the time of arrival requirements and needs, and we can plan the entire trip from point to point, the speeds that are needed, the average speeds that we need to achieve to arrive there and to maximize the hours of service of the driver. So this is fundamentally a different approach to semi-autonomous driving. It is an artificial intelligence fuel efficient driver assistance that allows the human driver to concentrate on steering, lane keeping, watching the environment, and not worrying about the pedal behavior and fuel efficient driving. And we will take care of that.
So how does things like changes in weather, or when a driver needs to intervene because of something unexpected, like how does that all work and impact the system, and how does the driver get notified of certain things? Like, I'd like to learn more. Let's start maybe just with weather. So you're driving, you're heading towards Colorado, and all of a sudden you get into the mountains and the weather suddenly changes, which does happen, especially in the winter time. How does the system know what's happening, and what does it tell the driver?
Yeah, our system has a user interface that runs on a smart device in the side field of view of the driver. It can run on the ELD device that the fleets already have, or we would provide a smart device. The UI, the user interface, provides cues about upcoming weather, such as snow, black ice, weather conditions, rain. We take the weather conditions into account when we're doing speed control. So we automatically reduce speeds to what the system considers to be safe operating speeds, or we alert the driver in cases where the driver should not engage the system at all. We alert the driver not to engage the system. Our weather telematics system that we interface with, they actually are AI based as well, and they're estimating surface friction and surface mu and upcoming black ice alerts and various weather alerts. And we're taking all of those into account to visually cue the driver in with ice signals and icons and snow signals and icons and heavy rain signals and icons, and optimize speed, lower the speed, and increase the following distances from other vehicles.
And if they need to intervene, it's just instant. They touch the pedals, or what happens there? Because like on traditional cruise control, the minute you touch the brake, cruise control's off. You have full control.
Yes.
How does that work with your system?
Yeah, it is very much identical to cruise control. So the use case is identical. It is engaged by turning the system on with the same cruise control switches. You can resume, you can set plus and minus and cancel. A brake pedal application immediately cancels the operation of the system. To go back into it, you need to hit resume. A throttle application will immediately allow the driver to override and speed up. And when the driver removes his foot from the throttle pedal, the system goes back into normal active engagement. Again, identical to cruise control or adaptive cruise control.
So I love the trucking industry, but We are a late adopting industry, and we are filled with much older people who have been doing this for decades oftentimes. How is the learning curve with drivers? It must take a bit of time for them to trust the system.
It does. It's like the adaptive cruise control for even our passenger car vehicles. First of all, adaptive cruise controls are not the same. A Honda's adaptive cruise control is going to be very different than a GM's adaptive cruise control. So the behavior matters a lot. What we have done is we have made it such that when the drivers drive, they immediately feel comfortable, and they say the common feedback that we got from drivers is that it drives the way I would. The common feedback that we get from riders in the vehicle when they go for a test ride is that we give them a demo, and then they come out and they say, what did they just see? Because they look at the feet, the driver's feet, and they're not on the pedal. Other than that, the vehicle seems very natural and normal as it's driving. So they feel like the driver was driving, and then they look over and they see that the driver is not driving. And that's what it takes to get the older drivers over the hump. The thing that the older drivers we saw they struggled with, and we have actually fixed that problem, is dealing with our user interface, putting in the map, putting in the routes, entering information into that. And we have a different version now. We have two versions, one that has map information and they need to put in destination and so on. And there's another version that they don't need to do any mapping. We work based on most probable path. So that long distance horizon that I mentioned to you, going a full 500-mile trip planning, we're not able to do that if they don't enter the route, enter the destination. But we're able to do everything else. So they're still getting a significant amount of benefit, and they're not shy about, oh, I can't enter this stuff, so I won't use the system. All they have to do is engage cruise control. They set cruise control, and as soon as they do that, they get all the benefits of the system. It is a connected solution, so we are constantly sending data back and forth, and we know which drivers are using it and which drivers are not. We have added features that the drivers can push a button and speak to it and register an issue and a complaint, or I'm not using it, I just wanted to do this and I can't do that. So we can hear the masses speaking back to us, to engineering, and over time, similar to the way when your Windows you would ask, send a report to the Windows, that data hopefully was looked at and things improved. Over time, we're improving our system based on that. And in fact, we're using AI and those button presses to label the data and then retrain our systems and look at it. So this gets better and better the more drivers they use it, the more vehicles are on the road, and the more these buttons are pressed.
So this is the heavy duty parts report. Let me ask you something. Have you put together any data on how the adaptive cruise control reduces wear on parts? Because I can tell you, as a sales account manager, when I was selling heavy duty parts, I heard many a repair technician curse out the drivers because they're too hard on the transmission, they're too hard on the brakes,
Yes.
they're breaking components, things like that. So I could see how this system, if it's lowering fuel, if it's making everything more efficient, it could also impact the amount of parts that need to be changed to keep the vehicle maintained.
Exactly. As you know, the regulations for maintenance are tied to fuel efficiency, because the industry knows better MPG vehicles are better maintained. So a vehicle that is more efficient, it means the engine was not stressed out, the transmission was not stressed out, and the brakes were not. So we are showing today in our testing, we're showing on-ramp to off-ramp 95% utilization by the drivers. When they're utilized, that means we're not applying brakes. So there is a significant amount of brake wear reduction. And we need to get longer term studies on other things. But we certainly are keeping the engine and transmission in their far more sweet spots than any driver could. The best drivers may be able to do that, but it's not that they could do it from the first hour of service till the 11th hour of service. Yeah. Our AI is doing it all the time. So the vehicles, when our system is engaged, they are driving in their sweet spots. So there will be, it seems kind of axiomatic that there will be some major benefits in parts wear out. But we need more data over time. And there are
Anecdotally,
companies that are working on diagnostics and they're collecting data. And over time, there is going to be also I'm sure you're going to ask this in a little bit, there's going to be an insurance cost reduction as well, because you have less accidents as well as less breakdowns.
right.
But
And
we need data.
anecdotally, we would assume that there's going to be widespread reduction on parts just based on the early data. So I'm really looking forward to when you get some more of that data. I'd love to have you back on the show to be able to show people the data and give them an even stronger case, not just fuel, not just lower insurance, not just lower driver costs, but also lower parts and maintenance costs. I think this is a total package. I think you and I could talk about this for another couple hours. We are coming to the end of our time, Ali, but maybe what you could do is, just as a way of concluding, just walk us through the step-by-step process if someone's interested in acquiring this system and installing it on one of their vehicles.
Well, I'd love to. And I'd love to come back and update you on the data, Jamie.
All right. It's a plan.
So if anyone is interested in getting this on their vehicles, give us a call, contact us. We are on www.traxen.ai. You go to the section where you request for a pilot. We survey you. We ask you some questions about what type of trucks do you have? What's your drive cycle? This is to help us understand customers' drive cycles. If we don't see a significant payback for you, we will tell you that maybe you shouldn't adopt it. So we want to help fleets reduce emissions, reduce their fuel costs, be more successful. And we don't want to just sell a product. So our first step is to pre-qualify that. Second step is we will provide you with a quote and work with you to schedule installers to come on site, meet you at the locations that you are, or if your trucks are available, to meet us at our installers' locations. The installation takes about 2.5 hours. It involves installing 3 radars external to the vehicle and our controller internal to the vehicle. The wiring harness routing, it's a 2.5 hour simple installation. Fleets have the option of running a pilot period. The pilot period could be a 4 to X amount of weeks. And we have data analytics and connected solutions that we can show you what you're getting for your fuel consumption and energy efficiency, or you can compare your prior fuel efficiency data to post-pilot fuel efficiency data. And we've had fleets do both methods. In fact, there is another method where we have had fleets run vehicles side by side. One had IQ Cruise and one did not, and they compare them. So all other conditions such as weather and time of day and traffic, everything else was equal. So the only difference was between human versus machine. So that would be the pilot process and installation process, Jamie.
You've been watching the Heavy Duty Parts Report. I'm your host, Jamie Irvin. Today, we've been speaking with Ali, who's the CEO of Traxen. If you want to learn more, he did mention Traxen.ai, but it redirects to .com. So we're going to put the links in the show notes as Traxen.com. That's TRAXEN.com. Links will be in the show notes. Ali, thanks for being our guest today. I appreciate it.
Thank you, Jamie. I appreciate being invited.
And I'm looking forward to having you back on the show when we can talk about all of that impact on parts. That's going to be great. Thank you. Thanks, Ali. We'll talk to you later.
Thank you. Cheers.
So that brings to conclusion our episode this week, and I'm looking forward to having you back. We'll be back next week. We're going to be having another great guest on, so tune in either on YouTube, Facebook, or on LinkedIn. And don't forget, go over to heavydutypartsreport.com if you want to see the replay of this live presentation. You can do so there and check out our podcast. Thanks so much for tuning in. We'll talk to you next week.